Water is life. It is the essence of our existence, the foundation upon which all living things thrive. From the smallest microorganisms to the largest mammals, every creature on Earth relies on water to survive and flourish. All living things depend on it. Without clean water, ecosystems would collapse, and life as we know it would cease to exist. The health of our planet is intricately linked to the availability of clean, fresh water. As our planet faces new challenges, finding clean water sources becomes even more vital. Climate change, pollution, and overpopulation are straining our water resources, making the quest for clean water more urgent than ever before. Scientists are working hard to develop new ways to purify water. Through innovative research and cutting-edge technology, they are discovering methods to remove contaminants and ensure that water is safe for consumption. Their goal is to make clean water accessible to everyone. By implementing these new purification techniques, communities around the world can have reliable access to this precious resource. It's a mission of hope for a brighter future. Clean water not only sustains life but also brings joy and prosperity to communities, fostering a sense of well-being and security. These advancements in science are truly inspiring. They demonstrate the power of human ingenuity and the relentless pursuit of solutions to some of the most critical issues facing our world today. They offer practical solutions to some of the world's most pressing problems. By harnessing technology and innovation, we can address water scarcity and ensure that everyone has access to clean, safe water. With ingenuity and dedication, we can ensure a healthy planet for generations to come. The promise of clean water is not just a dream, it is a tangible goal that we can achieve together for the benefit of all life on Earth. The Nile River is a lifeline for Egypt. Stretching over 6,650 kilometers, it is the longest river in the world and has been the cradle of Egyptian civilization for thousands of years. Its waters have nurtured the land, enabling agriculture and sustaining communities along its banks. For centuries, it has provided water for drinking, farming, and life itself. The river's annual flooding deposited nutrient-rich silt onto the farmlands, ensuring bountiful harvests and supporting the livelihoods of countless families. Today, this precious resource faces a serious threat: heavy metal contamination. Industrialization and urbanization have led to the discharge of toxic substances into the river, compromising its quality and endangering the ecosystem. Industries and factories often release harmful substances like lead and mercury into the water. These pollutants come from various sources, including mining operations, manufacturing plants, and improper waste disposal practices. These heavy metals can have devastating effects on human health. When ingested, they accumulate in the body, leading to chronic health issues such as kidney damage, neurological disorders, and developmental problems in children. They can cause serious illnesses and long-term damage to organs. The impact on public health is profound, with increased cases of cancer, cardiovascular diseases, and other life-threatening conditions. Protecting the Nile from this pollution is crucial for the well-being of millions of Egyptians. Efforts are underway to implement stricter regulations, improve waste management, and promote community-led initiatives to clean and preserve this vital waterway for future generations. In a groundbreaking discovery, Egyptian researchers have developed a remarkable solution using a common ingredient: wheat flour. By transforming this everyday staple into a specialized hydrogel, they have found a way to remove heavy metals from contaminated water. This innovative hydrogel acts like a sponge, attracting and trapping the heavy metals within its network. The process is efficient, cost-effective, and environmentally friendly. It's a testament to the power of human ingenuity in tackling complex challenges. Section 4. Egypt's Hope: Clean Water for All. The implications of this breakthrough for Egypt are immense. By implementing this hydrogel technology, Egypt can purify its water sources, ensuring the health and well-being of its people. Clean water means healthier lives, stronger communities, and a brighter future. This innovation also promises economic benefits. Access to clean water improves productivity and reduces healthcare costs. It's a win-win situation for both people and the environment. Section 5. A future of sustainable innovation. The development of this wheat flour-based hydrogel is a beacon of hope. It represents a significant step forward in our quest to find sustainable materials that can replace traditional, less eco-friendly options. This innovative hydrogel is not only biodegradable but also highly efficient in its applications, making it a versatile solution for various environmental challenges. It demonstrates the power of science to provide sustainable solutions for a better future. The collaborative efforts of scientists and researchers are paving the way for groundbreaking discoveries that can transform our world. This hydrogel, for instance, has the potential to revolutionize water purification processes, ensuring access to clean water for communities around the globe. By investing in research and innovation, we can overcome the challenges we face and create a more equitable and sustainable world. The commitment to scientific advancement is crucial in addressing pressing issues such as climate change, resource scarcity, and environmental degradation. Through continuous innovation, we can develop technologies that not only mitigate these problems but also promote a healthier planet. This breakthrough is not just about clean water, it's about the health of our planet and the well-being of generations to come. Clean water is a fundamental human right, and ensuring its availability is essential for the prosperity of future generations. The success of this hydrogel technology highlights the importance of sustainable practices in preserving our natural resources. It's about harnessing the power of nature to create a brighter future for all. By integrating nature-based solutions with scientific innovation, we can develop resilient systems that support both human and environmental health. This holistic approach is key to achieving long-term sustainability and ensuring a thriving planet for all its inhabitants. Hey there, science enthusiasts! Welcome back to another exciting episode where we dive deep into the wonders of science and technology. Today I'm thrilled to share some groundbreaking research that tackles one of our planet's most pressing issues: heavy metal contamination in water. This is a problem that affects millions of people worldwide, leading to severe health issues and environmental damage. Imagine a future where our polluted water sources are transformed back into clean, safe havens. A future where every drop of water is free from harmful contaminants. This isn't just a dream, it's becoming reality thanks to innovative hydrogels. These remarkable materials are paving the way for a cleaner, healthier world. These superabsorbent hydrogels, made from nothing more than wheat flour and acrylamide, have been supercharged using radiation techniques. This unique combination makes them incredibly effective at absorbing heavy metals. See, yep, you heard that right, radiation. This advanced technique enhances the hydrogel's properties, making them more efficient at capturing toxic substances. This process dramatically boosts their ability to capture harmful mercury and lead ions from wastewater. Imagine the impact this could have on our rivers, lakes, and oceans. The study, officially titled Radiation Synthesis of Superabsorbent Hydrogel, Wheat Flour Acrylamide for Removal of Mercury and Lead Ions from Waste Solutions, was published in the Journal of Inorganic and Organometallic Polymers and Materials back in 2020. This publication highlights the significant advancements made in this field. Let's take a moment to appreciate the brilliant minds behind this, the dedicated researchers who have worked tirelessly to bring this innovation to life. Associate Professor Dr. Ehab ElSayed Khozemy, a leading expert in polymer science, Associate Professor Dr. shaimaa.nasef, whose work in environmental chemistry is groundbreaking, and Associate Professor Dr. Tarek Mohamed, a pioneer in radiation technology. They hail from the Polymer Waste Recycling Lab at the National Center for Radiation Research and Technology in Cairo, Egypt. This institution is at the forefront of research in this field. These scientists have developed a material that could revolutionize how we approach environmental cleanup. Their work is not just about science, it's about creating a sustainable future for all of us. Picture this, a hydrogel that can soak up toxic metals from our water sources, making them safe again. This could be a game changer for communities around the world. It's like having a super sponge that can save our ecosystems. This technology has the potential to restore balance to our natural water systems. Interested in diving deeper into this topic? There's so much more to explore and understand about these innovative hydrogels and their applications. I'd love to hear your thoughts and questions, so drop them in the comments below. Your curiosity and engagement are what make these discussions so enriching. Your engagement fuels these fascinating discussions on cutting-edge science. Together, we can explore the wonders of innovation and discovery. So stay tuned to For Science Salah Lotfy channel for more incredible insights into the latest scientific innovations. We have so much more to share with you. Thanks for watching, and I'll then keep exploring and stay curious.
Hey there, science fans. Today we're diving into the amazing world of clean water technology. It's a big deal, right? We all need clean water to survive. And guess what? Scientists have developed an incredible new tool for purifying water using something you probably have in your kitchen right now: wheat flour. This isn't your grandma's gravy, folks. This is cutting-edge science. Researchers have created a special material called a hydrogel. Imagine a superabsorbent sponge, but instead of cleaning up spills, it sucks up dangerous heavy metals from contaminated water. This hydrogel is revolutionizing water purification. It's effective, affordable, and made from renewable resources. Now that's what I call a recipe for a healthier planet. Now you might be wondering, what's so bad about heavy metals in our water? Well, they're invisible to the naked eye, but they can cause some serious problems. We're talking lead, mercury, arsenic, nasty stuff. These heavy metals can seep into our water supply from industrial waste, mining activities, and even naturally occurring deposits. And when they get into our bodies, they can build up over time, leading to all sorts of health issues. Think about it. We drink water, we cook with water, we need water for everything. That's why it's so important to remove these heavy metals from our water supply, and that's where our superabsorbent hydrogel comes in. So, how does this incredible hydrogel actually work? Picture this: we take ordinary wheat flour, a staple found in kitchens around the world, and transform it into something extraordinary. The magic begins when we mix the wheat flour with a special ingredient called acrylamide. Acrylamide is a compound that, when combined with wheat flour, starts a fascinating chemical reaction. But that's not all. To complete the transformation, we expose this mixture to gamma radiation. Now you might be wondering, is this safe? Absolutely. Gamma radiation is carefully controlled and used in many scientific processes. This exposure to gamma radiation creates a network of tiny interconnected pores within the material. Imagine a sponge, but on a microscopic level. These pores are what make the hydrogel superabsorbent and highly effective. When contaminated water passes through the hydrogel, those heavy metal ions are attracted to the surface of the pores and get trapped. It's a bit like a magnet pulling in metal shavings, ensuring that the harmful particles are captured. Think of it as a microscopic net that captures the bad stuff, leaving you with cleaner, safer water. This process is not only efficient, but also incredibly effective at purifying water. And the best part? This hydrogel is incredibly effective at removing lead and mercury, two of the most dangerous heavy metal contaminants found in water. By using this innovative material, we can make a significant impact on water safety and public health. The potential applications of this wheat-based hydrogel are vast, from industrial water treatment plants to household water filters. This technology can be scaled to meet various needs. Imagine having a simple yet powerful tool to ensure the water you drink is free from harmful contaminants. This innovation not only promises cleaner water, but also a healthier future for communities around the world. By harnessing the power of wheat and science, we are taking a significant step towards solving one of the most pressing environmental challenges of our time. Now, I know what you're thinking. Bill, how do we know this thing really works? Great question. Scientists have used some high-tech tools to study the hydrogel and prove its effectiveness. One technique is called Fourier Transform Infrared Spectroscopy, or FTIR for short. It helps identify the different chemical bonds present in the hydrogel and how they interact with heavy metals. Another method is scanning electron microscopy, or SEM, which provides detailed images of the hydrogel's surface and pores. We also use X-ray diffraction, or XRD, to analyze the hydrogel's crystal structure, and energy dispersive X-ray spectroscopy, or EDX, to determine the elemental composition of the material. All these fancy techniques confirm that our hydrogel is a powerful tool for removing heavy metals from water. Section 5, From Farm to Filter. Why wheat flour? You might be wondering, why wheat flour? Well, for starters, it's abundant, renewable, and inexpensive, but it's not just about being budget-friendly. Wheat flour contains a special ingredient called starch, which plays a crucial role in the hydrogel's effectiveness. Starch is a natural polymer, which means it's made up of long chains of molecules. These chains act like building blocks, providing structural support to the hydrogel and enhancing its ability to absorb water. Plus, starch is biodegradable, meaning it breaks down naturally in the environment. How cool is that? Section 6, a win-win solution, benefits for the environment and our wallets. This wheat-based hydrogel isn't just a scientific breakthrough, it's a game changer for the environment and our wallets. Imagine a solution that not only addresses environmental concerns, but also offers significant economic benefits. This hydrogel does just that. Let me break it down for you. First off, it's environmentally friendly. By utilizing wheat flour, a renewable resource, we are tapping into a sustainable cycle that can be maintained indefinitely. This is crucial in our fight against climate change and environmental degradation. We're using a renewable resource, wheat flour, and the hydrogel itself is biodegradable. This means it breaks down naturally without leaving harmful residues, unlike many synthetic materials that persist in the environment for years. That means less waste and a smaller environmental footprint compared to traditional water purification methods. Second, it's cost-effective. Traditional methods often involve expensive and complex machinery, but this hydrogel simplifies the process. Wheat flour is readily available and inexpensive, making this technology accessible to a wider range of communities, especially in developing countries where access to clean water is often limited. This affordability can lead to widespread adoption, improving public health on a global scale. And lastly, it's highly efficient. Efficiency is key when it comes to water purification, and this hydrogel excels in that area. It can purify large volumes of water quickly and effectively. The hydrogel can remove a significant amount of heavy metals from water, making it a valuable tool for both large-scale water treatment plants and individual households. This versatility ensures that clean water is accessible to everyone, from urban centers to remote villages. In summary, this wheat-based hydrogel is a revolutionary solution that benefits both the environment and our wallets, paving the way for a more sustainable and equitable future. Section 7. Beyond drinking water, the future of hydrogel technology. The future of this hydrogel technology is bright, and it goes beyond just cleaning our drinking water. Scientists are exploring its potential in various fields, and the possibilities are truly exciting. Imagine using this hydrogel to clean up industrial wastewater, removing harmful pollutants before they reach our rivers and oceans. Or picture using it in agriculture to create drought-resistant soils that can better retain water and nutrients. Researchers are even investigating its use in biomedical applications, such as drug delivery systems and wound healing. The ability of this hydrogel to absorb and release substances in a controlled manner makes it a promising candidate for various medical treatments. Section 8, Conclusion A. Cleaner tomorrow, one drop at a time. Clean water is essential for all life on Earth. It is the lifeblood of our planet, nourishing ecosystems, supporting biodiversity, and sustaining human communities. Without clean water, life as we know it would not be possible. From the tiniest microorganisms to the largest mammals, every living being depends on this precious resource. And this revolutionary hydrogel, made from wheat flour, is a major step forward in our fight against water pollution. This innovative material has the potential to transform how we approach water purification, making it more accessible and efficient. By leveraging the natural properties of wheat flour, scientists have created a solution that is both sustainable and effective. It's a shining example of how science and innovation can be used to create a healthier, more sustainable future for everyone. The collaboration between researchers, engineers, and environmentalists is paving the way for groundbreaking advancements that can address some of the most pressing challenges of our time. By harnessing the power of nature and combining it with cutting-edge technology, we can develop solutions that are not only effective but also environmentally friendly. This synergy between nature and technology is key to creating a sustainable future where both people and the planet can thrive. We can make a real difference in the world, one drop of clean water at a time. Remember, even small actions like conserving water in our daily lives can collectively lead to significant positive impacts. Simple habits such as turning off the tap while brushing your teeth, fixing leaks promptly, and using water-saving appliances can contribute to a larger movement towards water conservation. Like conserving water in our daily lives, these small changes can add up to make a big difference. Every drop saved is a step towards a more sustainable future. Community efforts, such as reforestation projects near water bodies and beach cleanups, play a crucial role in protecting our water resources. These collective actions help to maintain the health of our ecosystems and ensure that clean water remains available for future generations. So let's all do our part to protect our precious water resources, whether it's through individual actions or community initiatives. Every effort counts, and ensure a brighter future for generations to come. Stay curious, stay informed, and keep exploring the amazing world of science. By staying engaged and educated, we can continue to support and drive the innovations that will lead to a cleaner, healthier planet. Together, we can make a difference. Let's embrace the power of science and technology to create a cleaner tomorrow, one drop at a time.
Water is life. We all know this. But did you know that access to clean water is a growing problem? Pollution from heavy metals is a major threat. These toxic substances contaminate our rivers, lakes, and groundwater. This is a serious danger to human health and the environment. Scientists are working hard to find solutions. One promising approach uses hydrogels. Hydrogels are amazing materials. They act like giant sponges, soaking up water and other substances. Now researchers are using gamma radiation to create hydrogels that can remove heavy metals from water. This is a groundbreaking development. It could revolutionize water treatment and provide clean water for millions. Hydrogels are made from polymers. Polymers are long chains of molecules. Think of them like tiny beads strung together. These chains are cross-linked to create a three-dimensional network. This network can absorb and retain large amounts of water. Two key ingredients in our hydrogel are acrylamide and wheat flour. Acrylamide is a synthetic material. It provides the hydrogel with its ability to absorb water. Wheat flour, a natural product, acts as a backbone. It provides structural support to the hydrogel. These materials are readily available and inexpensive. This makes the hydrogel synthesis process cost-effective and scalable. It has the potential to be implemented in developing countries where access to clean water is limited. Making the hydrogel is like baking a cake, but with a scientific twist. We start by dissolving acrylamide and wheat flour in water. This creates a viscous solution. Think of it as our batter. Next, we expose this mixture to gamma radiation. Gamma radiation is a high-energy form of electromagnetic radiation. It initiates a process called polymerization. The gamma rays break down the acrylamide molecules. This allows them to link together and form long chains. The wheat flour acts as a binder, helping the acrylamide chains to cross-link. This cross-linking creates the three-dimensional network that gives the hydrogel its superabsorbent properties. Our hydrogel swells and gels. Swelling absorbs water like a sponge. Gelation transitions it to a gel state. Crosslinks give it structure. These properties help remove heavy metals. Section 5. Seeing the unseen. How scientists study hydrogels. Scientists use advanced techniques to study the hydrogel's structure and properties. These techniques provide valuable insights into the material's behavior. One such technique is Fourier transform infrared spectroscopy, or FTIR. FTIR helps identify the different chemical bonds present in the hydrogel. It confirms the successful cross-linking of the polymer chains. Scanning electron microscopy, or SEM, provides high-resolution images of the hydrogel surface. This reveals the porous structure of the material. Energy dispersive X-ray spectroscopy, or EDX, analyzes the elemental composition of the hydrogel. It confirms the presence of heavy metals absorbed by the material. X-ray diffraction, or XRD, helps determine the crystalline structure of the hydrogel. This information is crucial for understanding the material's mechanical properties and stability. Section 6. Hydrogel to the rescue, soaking up heavy metal pollution. The hydrogel's effectiveness in removing heavy metals from water has been extensively studied. Experiments show that the hydrogel can absorb significant amounts of heavy metals like lead, mercury, and cadmium. The adsorption process is driven by a combination of factors. These include electrostatic interactions, chelation, and physical adsorption. The hydrogel's surface contains functional groups that attract and bind to the heavy metal ions. The hydrogel's porous structure also plays a role. It provides a large surface area for the heavy metal ions to interact with. This makes the hydrogel a highly efficient adsorbent for heavy metal removal. Section 7. A matter of preference. Hydrogel's taste for toxic metals. The hydrogel selectively adsorbs heavy metals. It prefers lead and mercury over cadmium. This is due to the hydrogel's functional groups. Size and charge of ions play a role. This selectivity aids in water purification. Section 8. A cleaner. Tomorrow, hydrogel's promise for the environment. Gamma radiation synthesized hydrogel holds immense potential for environmental remediation. It efficiently removes heavy metals from water, ideal for water treatment. Useful in treating industrial wastewater and contaminated groundwater, its low cost and ease of synthesis make it viable for developing countries, a sustainable, affordable solution for the global water crisis. Have you ever seen a diaper absorb water? It's like magic, right? You pour water onto it and it just disappears, leaving the surface dry. But have you ever wondered how this happens? What makes a diaper so incredibly absorbent? The secret lies in tiny materials called hydrogels. These are special polymers that can hold a lot of water relative to their size. When they come into contact with water, they swell up and trap the liquid inside. These amazing substances can soak up and hold a lot of water, much like a sponge. Imagine a sponge that can hold hundreds of times its weight in water. That's what hydrogels can do. Hydrogels are like tiny superheroes, working hard to solve big problems. They are used in a variety of fields, from medicine to environmental science. Their ability to absorb and retain water makes them incredibly versatile. They help deliver medicine, clean up spills, and even grow plants. In medicine, hydrogels can be used to release drugs slowly over time, ensuring that patients get the right amount of medication. In environmental science, they can be used to clean up oil spills by absorbing the oil. One of the coolest things about hydrogels is that they can be made from all sorts of things. This means that scientists can tailor them for specific uses. For example, some hydrogels are designed to be biodegradable, making them more environmentally friendly. Some are made from synthetic materials which are made in a lab. These synthetic hydrogels can be engineered to have specific properties, such as increased strength or faster absorption rates. Others are made from natural materials, like the flour in your kitchen. These natural hydrogels are often used in applications where biodegradability is important, such as in agriculture. Scientists are always looking for new and better ways to make hydrogels. They experiment with different materials and methods to improve their performance. This ongoing research is crucial for developing new applications and making existing ones more efficient. They want to make them even better at absorbing water and doing other important jobs. The future of hydrogels is bright, with endless possibilities for innovation and improvement. So, next time you see a diaper in action, remember the tiny sponges with a big job. Remember that flour we talked about? Well, it's not just for baking cookies. Flour is actually a great starting point for making super absorbent hydrogels. Flour contains starch, a natural polymer. Polymers are like long chains made up of smaller building blocks, all linked together. Think of a pearl necklace, where each pearl is a building block. These starch chains in flour can be linked together even more, creating a network that can trap water. It's like weaving a net to catch all the water molecules. But to make a truly super absorbent hydrogel, we need to add another ingredient to our recipe. That's where acrylamide comes in. Acrylamide is a small molecule that acts like a knitting needle. It helps connect the starch chains in flour even more tightly, creating a stronger and more absorbent hydrogel. Imagine taking our pearl necklaces and using the acrylamide needles to connect them together, forming a big, strong net. The more acrylamide we add, the more tightly knit our hydrogel becomes. This means it can hold even more water. But we have to be careful because too much acrylamide can make the hydrogel stiff and difficult to work with. It's all about finding the right balance. Now let's talk about sunshine. Did you know that we can use radiation from the sun, or even special lamps, to make our hydrogels even stronger? It's true, this process is called irradiation. When we expose our flour and acrylamide mixture to radiation, it causes even more connections to form between the starch chains. It's like using the sunshine to weld our pearl necklace net together, making it super strong and durable. By controlling the amount of radiation, we can fine-tune the properties of our hydrogel, making it perfect for different jobs. So, just how much water can these flour and acrylamide hydrogels hold? You won't believe it! They can absorb hundreds of times their own weight in water. That's like a single drop of water turning into a whole puddle. The secret to their incredible water-absorbing ability lies in the structure we talked about earlier. The tightly knit network of starch chains creates lots of tiny spaces for water molecules to get trapped. It's like a giant water park for water molecules. But remember, finding the right balance of flour and acrylamide is key to maximizing water absorption. Section 6. Looking closely. How scientists study these tiny sponges. Now these hydrogels may be small, but scientists have some pretty cool tools to study them. One tool is called a scanning electron microscope, or SEM for short. This powerful microscope uses electrons instead of light to create images of our hydrogels, allowing us to see their surface in amazing detail. Another tool is called Fourier Transform Infrared Spectroscopy, or FTIR. This technique helps us identify the different types of chemical bonds present in our hydrogels. It's like taking a fingerprint of our hydrogel, revealing its unique chemical makeup. Section 7. X-ray vision, seeing the inside of our sponge. Remember how Superman uses X-ray vision to see through things? Well, scientists have their own version of X-ray vision. They use techniques like X-ray diffraction and energy dispersive X-ray spectroscopy, or EDS, to study the internal structure and composition of our hydrogels. X-ray diffraction helps us understand how the starch chains are arranged inside the hydrogel. Are they neatly ordered or randomly arranged? This information helps us understand why some hydrogels are more absorbent than others. EDS, on the other hand, tells us which elements are present in our hydrogel and in what quantities. It's like having a chemical inventory for our tiny sponge. Section 8. Heavy metal busters, cleaning up with our sponge. Here's where things get really exciting. Our team of dedicated scientists has been working tirelessly to develop a revolutionary material that can help tackle one of the most pressing environmental issues of our time. Remember how we talked about hydrogels being like superheroes? Well, these incredible materials are about to show you just how powerful they can be. These flour and acrylamide hydrogels have a very important superpower. They can remove heavy metals from water. Imagine a sponge that not only soaks up water but also traps harmful substances within it. Heavy metals like lead and mercury are dangerous pollutants that can contaminate our water supplies. These metals can cause severe health issues, including neurological damage and kidney problems, if ingested over time. But our superabsorbent hydrogels can act like magnets, attracting and trapping these harmful metals, effectively removing them from water. This means cleaner, safer water for everyone. This process is called adsorption. The best part? It's not just a one-time use. These hydrogels can be reused multiple times without losing their effectiveness. These hydrogels are extremely efficient at removing heavy metals, even at very low concentrations. This means they can clean up even the most minuscule traces of pollutants, ensuring the highest quality of water purification. This makes them a promising solution for cleaning up polluted water and protecting our environment. By using these hydrogels, we can make significant strides towards a cleaner, healthier planet for future generations. Imagine the impact on communities around the world, where access to clean water is a daily struggle. Our hydrogels could be the key to unlocking a brighter, more sustainable future. Section 9. A cleaner future. How super sponges can help our planet. The future looks bright with these incredible flour and acrylamide hydrogels. These materials, often referred to as super sponges, have the potential to revolutionize how we manage water resources and environmental pollutants. By harnessing their unique properties, we can address some of the most pressing environmental challenges of our time. Their amazing water absorption capacity and heavy metal removal abilities make them ideal for a wide range of applications. These hydrogels can absorb many times their weight in water, making them perfect for areas prone to drought or water scarcity. Additionally, their ability to filter out harmful heavy metals from water sources can help protect both human health and the environment. Imagine using them to clean up industrial wastewater, which is often laden with toxic substances that can harm ecosystems and human communities. By integrating these hydrogels into wastewater treatment processes, we can significantly reduce the environmental impact of industrial activities. Purify drinking water in developing countries, where access to clean water is a critical issue. These hydrogels can be used in portable water purification systems, providing safe drinking water to communities that lack reliable water infrastructure. This can have a profound impact on public health and quality of life, or even remove pollutants from our oceans. Marine pollution is a growing concern, with plastics and other contaminants threatening marine life and ecosystems. Hydrogels could be deployed in ocean cleanup efforts, helping to restore the health of our oceans and protect marine biodiversity. But it doesn't stop there. The versatility of these hydrogels means they have potential applications beyond water management and environmental cleanup. These hydrogels also hold great promise in agriculture, where they can be used to create self-watering systems for crops. By retaining moisture in the soil, they can reduce the need for frequent irrigation, conserving water and helping farmers maintain healthy crops even in arid conditions. Reducing water consumption and improving crop yields. This can lead to more sustainable farming practices and increased food security, especially in regions facing water shortages and unpredictable weather patterns. Farmers can benefit from higher yields and more resilient crops, contributing to a more stable and productive agricultural sector. They can also be used in biomedical applications, such as wound healing and drug delivery. Hydrogels can provide a moist environment that promotes faster healing and reduces the risk of infection. In drug delivery, they can be engineered to release medications at a controlled rate, improving treatment outcomes, such as wound healing and drug delivery. The possibilities are endless. The medical field stands to gain significantly from the innovative use of hydrogels, potentially transforming patient care and treatment methodologies. By continuing to explore and develop these incredible materials, we can unlock new solutions to some of the world's most challenging problems. The ongoing research and development in this field are crucial for realizing the full potential of hydrogels. We can create a cleaner, healthier, and more sustainable future for all. The integration of hydrogels into various sectors can lead to significant environmental and societal benefits, paving the way for a greener planet. And that's something worth getting excited about. The potential of these super sponges is truly remarkable, and their impact on our planet could be transformative. Let's embrace this technology and work towards a brighter future together. Water is life. This simple truth binds us all. Yet this precious resource is under threat. Heavy metals like mercury and lead pollute our waters. These contaminants pose serious risks to human health and the environment. We need innovative solutions to combat this invisible enemy. Enter FPAM Hydrogel, a remarkable material with the potential to revolutionize water purification. This copolymer hydrogel acts like a sponge, drawing in and trapping heavy metal ions. Imagine a microscopic net, selectively capturing and removing these harmful substances from water. This technology offers hope for a cleaner, healthier future. The effectiveness of FPAM hydrogel is influenced by several factors. One crucial factor is pH, which measures the acidity or alkalinity of a solution. The pH level affects the charge of both the hydrogel and the metal ions. At a pH of 6, FPAM hydrogel demonstrates the highest adsorption capacity. Why is this specific pH level optimal? At pH 6, the hydrogel's surface charge becomes ideal for attracting and binding heavy metal ions. This sweet spot maximizes the material's ability to remove these contaminants from water. Imagine a crowded room. It's bustling with people, everyone talking, moving, and interacting. The air is filled with a mix of conversations, laughter, and the clinking of glasses. Now imagine trying to move through that room as more and more people arrive. The space becomes tighter, and navigating through the crowd becomes increasingly difficult. Each new person adds to the complexity of movement. This scenario is quite similar to how concentration affects the adsorption process in chemistry. When the concentration of molecules increases, the competition for available spaces intensifies. A higher initial concentration of heavy metal ions means there are more ions competing for available binding sites on the hydrogel. Each ion is like a person trying to find a spot in that crowded room. Temperature also plays a crucial role in this process. Just as the atmosphere in a room changes with temperature, so does the behavior of molecules. Think of heating up a pot of water. As the temperature rises, the water molecules begin to move more vigorously. The hotter the water gets, the faster the molecules move. This increased movement is due to the added energy from the heat. Similarly, increasing the temperature enhances the adsorption process. The added heat provides more energy to the molecules, making them move faster and interact more frequently. The heat provides more energy to the metal ions, allowing them to move more quickly and increasing their chances of encountering and attaching to the hydrogel. This increased interaction rate can significantly improve the efficiency of the adsorption process, making it more effective in capturing contaminants. Scientists use models to understand how fast adsorption occurs. Two common models are pseudo-first-order and pseudo-second-order kinetics. These models help us predict how quickly the hydrogel can remove heavy metals from water. The pseudo-second-order model proves to be a better fit for FPAM hydrogel. This model suggests that the rate of adsorption depends on both the concentration of heavy metal ions and the availability of binding sites on the hydrogel. Understanding the kinetics of adsorption is crucial for designing efficient water treatment systems. Section 5. A deeper dive. Let's zoom in on the adsorption process. Adsorption is a critical mechanism in water purification, especially when dealing with contaminants like heavy metals. It involves the adhesion of atoms, ions, or molecules from a gas, liquid, or dissolved solid to a surface. This process is essential for removing impurities from water, making it safe for consumption and use. Imagine the hydrogel as a vast network of interconnected tunnels and chambers. This intricate structure is what makes hydrogels so effective in trapping and holding on to contaminants. The network is composed of polymer chains that create a porous matrix, allowing water and other substances to pass through while capturing unwanted particles. Heavy metal ions navigate this labyrinthine structure in two distinct stages: surface adsorption and intraparticle diffusion. During surface adsorption, ions are attracted to and held on the surface of the hydrogel. This initial stage is crucial as it determines the hydrogel's capacity to capture contaminants. Surface adsorption is like finding a parking spot on a busy street. The ions first attach to the outer surface of the hydrogel, much like cars lining up along the curb. This process is relatively quick and efficient, allowing the hydrogel to capture a significant amount of contaminants in a short period. The ions first attach to the outer surface of the hydrogel. This initial attachment is driven by various forces including electrostatic attraction and van der Waals forces. These forces help to hold the ions in place, preventing them from easily detaching and re-entering the water. Once the surface becomes saturated, the ions begin to move into the interior of the hydrogel. This movement is driven by a concentration gradient, where ions move from areas of higher concentration to areas of lower concentration within the hydrogel. This second stage, intraparticle diffusion, is like finding a parking spot in a multi-level parking garage. The ions must navigate through the complex network of pores and channels within the hydrogel, much like cars searching for a spot in a crowded parking structure. The ions slowly diffuse through the hydrogel's pores, eventually filling the available binding sites. This process ensures that the hydrogel can capture and hold a large number of contaminants, making it an effective tool for water purification. The combination of surface adsorption and intraparticle diffusion allows the hydrogel to maximize its contaminant capturing capacity, ensuring cleaner and safer water. Section 6. A tale of two isotherms. Scientists use isotherms to describe how much of a substance can be adsorbed onto a material. Two well-known isotherms are the Langmuir and Freundlich models. These models provide insights into the adsorption capacity of different materials. For FPAM hydrogel, the Freundlich isotherm proves to be a better fit. This model suggests that the adsorption process is not limited to a single layer of ions on the hydrogel's surface. Instead, multiple layers can form, increasing the overall adsorption capacity of the material. Section 7. Beyond adsorption. While adsorption is a powerful tool for removing heavy metals, it's not the only weapon in our arsenal. Scientists around the world are constantly seeking new methods and technologies to improve water purification. Adsorption, though effective, has its limitations, and overcoming these limitations is crucial for advancing our capabilities. Scientists are exploring ways to enhance the performance of FPAM hydrogel even further. This involves not just understanding the fundamental properties of the hydrogel, but also innovating new techniques to make it more efficient. Research teams are collaborating across disciplines, combining chemistry, materials science, and environmental engineering to push the boundaries of what's possible. One promising approach is to modify the hydrogel's surface with specific functional groups. These functional groups can be tailored to interact with particular contaminants, making the hydrogel more selective and effective. By attaching these groups, we can enhance the hydrogel's ability to target and bind with specific heavy metals, thereby increasing its purification efficiency. These groups can act like molecular hooks, selectively capturing and removing specific types of heavy metal ions. Imagine these hooks as tiny, specialized tools designed to latch onto contaminants with precision. This selective binding not only improves the removal process but also ensures that the hydrogel can be reused multiple times without losing its effectiveness. Imagine a team of specialized cleanup crews, each equipped to handle a different type of hazardous waste. Each crew member has a unique skill set tailored to address specific contaminants. This analogy helps us understand how functionalizing the hydrogel surface can create a versatile and powerful tool for water purification. That's essentially what we're doing by tailoring the hydrogel surface with specific functional groups. This customization allows us to design hydrogels that are highly specialized for different contaminants, making the purification process more efficient and effective. The ability to customize the hydrogel opens up new possibilities for addressing a wide range of water pollution challenges. This customization allows us to create even more effective and targeted water purification systems. By fine-tuning the hydrogel's properties, we can develop solutions that are not only more efficient but also more sustainable. The future of water purification lies in these advanced materials and the innovative approaches that scientists are developing today. Section 8. FPAM Hydrogel, a beacon of hope. FPAM hydrogel represents a significant advancement in water purification technology. Its ability to effectively remove heavy metal ions from water, even at low concentrations, makes it a promising solution for addressing this global challenge. The hydrogel's high adsorption capacity, combined with its tunable properties, opens up new possibilities for creating sustainable and efficient water treatment systems. Imagine a world where clean, safe water is readily available to all. FPAM hydrogel brings us one step closer to realizing this vision. Section 9. Our water, our future. Water is the lifeblood of our planet. Protecting this precious resource is not just an environmental imperative, it's a matter of survival. Innovative technologies like FPAM hydrogel offer hope for a cleaner, healthier future. By investing in research and development, we can unlock the full potential of these solutions and ensure access to safe water for generations to come. The future of our planet depends on the choices we make today. Let's choose to protect our water resources and create a brighter future for all. Hey everyone, welcome back to another exciting episode of For Science Salah Lotfy channel. Today we have something truly groundbreaking to discuss that could revolutionize the way we handle one of the most pressing environmental issues of our time. Today, I'm diving into some groundbreaking research that could change the way we handle polymer waste. This isn't just any research, it's a pioneering effort that promises to transform our approach to recycling and waste management. That's right, we're talking about innovative solutions for recycling polymer waste into valuable resources. Imagine a future where the plastic waste we generate daily is no longer a burden, but a valuable asset. Now, imagine a world where our plastic waste isn't clogging up landfills or polluting our oceans, but instead being transformed into something useful. This vision is not just a distant dream, but a tangible reality that researchers are working towards every day. Sounds like a sci-fi dream, right? But thanks to the relentless efforts of scientists and researchers, this dream is inching closer to reality. They are developing cutting-edge technologies that could redefine our relationship with plastic waste. Well, thanks to some incredible researchers, this dream is closer to reality than you might think. These scientists are pushing the boundaries of what's possible, exploring new methods and technologies to recycle polymers more efficiently and sustainably. These scientists are working tirelessly in laboratories, exploring new methods to recycle polymers. Their dedication and hard work are paving the way for a future where polymer waste is no longer a problem, but a solution. Their work is not only advancing our understanding of polymer chemistry, but also paving the way for new eco-friendly technologies. These advancements could lead to the development of new materials that are both sustainable and beneficial for various industries. Think about it. New materials that benefit both industry and the environment. These innovations could lead to the creation of products that are not only high quality, but also environmentally friendly, reducing our reliance on non-renewable resources. Let's give a shout out to the brilliant minds behind this study, the researchers who are making all of this possible. Their dedication and passion are truly inspiring. Associate Professor Dr. Ehab ElSayed Khozemy, a leading figure in this field, has been instrumental in driving this research forward. His expertise and vision are helping to shape the future of polymer recycling. Associate Professor Dr. shaimaa.nasef, she's the corresponding author you can reach at shaimaa.nasef at eea.org.eg. Her contributions to this research are invaluable, and she is a key player in the development of these innovative recycling methods. And let's not forget the team at the Polymer Waste Recycling Lab, Polymer Chemistry Department, National Center for Radiation Research and Technology, Atomic Energy Authority in Cairo, Egypt. Their collaborative efforts are driving this research to new heights. Oh, and let's not forget Associate Professor Dr. Tarek Mansour Mohamed. His work is also crucial in this groundbreaking research, contributing significantly to the advancements we are seeing today. These researchers are not just contributing to science, they're making a real difference in our quest for sustainability. Their work is helping to create a more sustainable future for all of us. Their innovative solutions could revolutionize how we manage polymer waste, turning a major environmental challenge into an opportunity for positive change. This could lead to a cleaner, healthier planet for future generations. Before I wrap up, I want to thank all of you for your continuous support and engagement. Your interest in these topics helps to drive awareness and change. Your thoughts and feedback are incredibly valuable. So don't forget to drop your opinions and comments on this research below the video. We love hearing from you, and your insights help us to bring you the content you care about. Stay connected with For Science Salah Lotfy channel, where we bring you the latest insights into scientific advancements. We are committed to keeping you informed about the most exciting developments in science and technology. See you in the next episode. Until then, stay curious and keep exploring the wonders of science.